Okay, just so that we have seen different types of nonlinear functions, we get to do cubic functions today. This is day 2 for chapter 7, section 5. So I guess you had a problem with a cubic function yesterday. That's what I hear. So we're going to go ahead and put one in your notes today. Okay? So how do you know that this function here, here's the model of a cubic function. How do we know it's a cubic function? What gives it away right away? Bella?
The exponent is 3.
The exponent is 3. So remember, what we're doing to the input tells us what type of function it is. Who can give me the parent linear function? Tessa.
Y equals x.
Good job. She says y equals x. Excellent. Extra credit for her, please. And who can give me the parent quadratic function? Lexi? Y equals, you could just say x squared. That's the parent one. Excellent. Good extra credit for you. And now we see that the cubic one is y equals x to the third. So it has to do with the exponent. Okay? Let's graph this and see what it looks like on the graph. And notice it has a negative, what number out here? A negative 1 in front. So how do we graph these nonlinear functions? What do you do to graph it? Mary?
You put input.
You got to put an input. So we're going to make a what?
Make a chart.
A chart, or we say a table. Okay, a table. And so what values do you think would be good to put in this table?
-2, -1, 0, and 0.
Good, so she's selecting a couple of negatives, a couple of positives, and 0. So that's nice because we can see that negatives sometimes have a dramatic effect, don't they, on what goes on in these kinds of functions. So we can go plug these things in and see what comes out. If we plug in 0 right now, I'm going to write the equation over here. If we plug in 0, what do we get out for y? 0. Okay. If we plug in -1, how am I going to plug that in? Who knows? This is a very delicate issue here. How do we plug it in? Tatum? I said -1, didn't I? But I moved down here to the positive. So can we plug in, we're going to plug in +1, so tell me how. Negative what? What is being cubed? 1? Good, she says 1. So I'm going to put what the x value in parentheses to show you that what is being cubed is the input. And then there is a -1 being multiplied to it out here. -1 is being multiplied to this thing that's being cubed. Now, in math, we don't have to show parentheses. You should know, looking at this original equation, that you're cubing just the x, the input, and then you're taking its opposite. Okay? So when that happens, Tatum, we cube the 1 and then we take its opposite. So what do we get? Good, we get -1 here. Let's try this with 2. Brandon, what do we get? -8. Okay, but let's go up here now to the negatives. And when we plug in -1, who can tell me what that's going to look like, just plugging it in? Lindsay?
Y equals negative parentheses -1 to the third.
Good. -1 is happening. Just the -1 is happening to the third. So what is -1 to the third?
1.
-1 times -1 times -1 is -1. And now we take the opposite, which is
+1.
1. So this is not exactly like plugging in 1, is it? This is different. Okay, and then when we plug in -2, you probably, some of you probably know what's going to happen. Riley? It's going to be a positive because we get negative of the -2 times -2 times -2 is -8, and now we take its opposite, so we get a +8. So go ahead and graph these. I'm going to pause this video so you can try. Okay, so we plot the 5 points and we draw a curve, and we no longer have a U-shaped curve. When we have a cubic function, cubing that input causes us to have what shape? Good job, S shape. So let's put a note down. These are S-shaped curves. So that should be a hint to you. If you are asked to graph an equation with a cubed input, you will have an S shape. If you don't have an S shape and you end up with a U shape, what happened?
You graphed it wrong.
Math error, probably a math error, unless you did graph it wrong, right? So make sure you're very careful with your inputs. Okay, we're going to try again with this one. We're going to put a value in front of the cubed expression here. So go ahead and make a table and come back and check it out. Making a table. So what are you doing, Sophia?
I did negative
Oops, I'm sorry. Gotta put X, right? Input, output. So you put -2.
negative 1, 0, 1, and 3.
Okay, and what do you want to plug in first? What would you like to plug in?
Oh,
Now plug in 0 first?
yeah.
What is 0 cubed?
0,
And 0 times 2?
0.
Good. What is 1 cubed? 1 times 1 times 1. 1. And what 1 times 2 is? So she says when you plug in 1 and cube it, right, you get 1. 1 times 1 times 1 is 1, and then 1 times 2 is 2. Let's plug in 2. And when you plug in 2, Sophia, what do you get? 2 times 2 times 2 is 8 times 2 is 16. Good. 16. Okay, but let's go up here and plug in these negatives. When you plug in -1, -1 times -1 times -1, we really should put the 3 out here, is -1, isn't it? And -1 times 2 is?
2, negative 2.
-2. So it's no longer positive, as it was when we plugged in 1, right? So how about -2, right? Good job, -16. -2 times -2 times -2 is -8 times 2, which is -16. Good. So now we go ahead and plot the points. Don't forget to label. And walk before you fly. So Jimena, where do I go?
You have to go on -2 to the left and down -16.
Ew, I don't see that here. I actually made this graph show a value of 1. You see that? I'm going to change my graph to be 2's in this direction. 20 here and -20 there. But I'm going to leave my x as 1 in each blue line, okay? So I have different scales. I've got to remember that though. So she says go -2 and down 16, which would be here.
And then you want to go over -1, down -2.
Which would be here, right? Because each blue line is 2 in my y direction.
And then it's 0, 0, so you just put down 0.
Okay.
And then it's over 1 to the right and up 2. And then over 2 to the right and up 16.
2, 4, 6, 8, 10, 12, 14, 16. Good. And now we draw the S shape. Ah. Very good. You know, you can go to my website and go under my Algebra 1 page, and you can click on my free, it's not mine, but it's a free graphing calculator that I have a link to here. And you can input these equations that we're talking about here. So notice that I can also choose the color I want it to be. You know, I can change the color like that. I'm going to leave that red. And the first equation I'm going to graph is y equals exactly what we just graphed. So I'm going to put an x, whoops, I forgot to highlight it, right? X, and then here's the upside down v, which means raise it to, right? The exponent, raise it to the exponent of, and I'm going to use my keyboard to put 3. Okay? So now all I have to do is click graph, And whoo, isn't that pretty? Now, just for fun, with the green one, I'm going to make a quadratic equation. What's the parent quadratic again? Y equals x squared. Oh, I could have just done that, huh? Oh, to square it. Let me see. Back it up, back it up. I need to hit x and square it. I could have cubed that one. Did you see that? Anyway, now when I hit this, you're going to see the red one is a cubed one, and the green one is the squared one. Aha, see that? And now let's, for fun, put our most basic linear equation. Y equals
X plus B.
Y equals X. That's the most basic parent equation. And this is blue. So let's see, it's going to do all three. Cubic, quadratic, linear. Isn't that cool? So just for fun, do you want to see to the fourth? You want to see the next one up? And let me do it in, how about that color, that purple, because it's, is that visible enough for you back there? Here we go, let's graph it. 1, 2, 3, and I don't see it. Oh, I didn't do it. Stop me when I'm silly like that. Okay, x to the fourth. Okay, here we go. Looking for the purple. 1, 2, 3. Oh, it's too small for you to see. Let me do this. Let me put a number in front of here. Is it there? Where is it? You know what's going on in here that you can't see? Here, let's zoom in and see. Can you see it yet? Now let's zoom in some more.
Oh, yeah.
I don't know if you can see. Zoom in some more. It's squiggling. It's going ever so slightly up right here. So it goes 1, 2, 3, 4. It has 4 turns because of that 4th degree. Okay? I wonder, oh there. Now let me do this. Let me multiply by 5. Let me zoom out a little bit. Okay, whoops, that's too far out. How about right here? And can we see it yet? No? No, it's hard to see, but it's a W shape. And if I actually put a negative in front, what do you think will happen? Very good. It's going to go upside down. Yay! Because it does the same as our quadratic or our cubic. As a matter of fact, let's do this. With our cubic, let's do just 2 cubics. But we'll make one of them negative and one of them positive. X to the 3rd. Okay, so in red is the positive and in blue is the negative. Isn't that interesting? It almost looks like they form 2 parabolas, but they're half colors, right?
Yeah.
Interesting. Okay. Okay, our final little topic today is, can you tell me if each of these graphs are functions? Now, we started off the last section talking about the difference between relations and functions, remember? 7.4. So we did that with tables. Remember all those tables you drew and you were looking to see what? How do you know if you have a function? Do you remember? Every what has what? You remember, Sophia? Every input has exactly one output. So that means every x has exactly one y. So when we look at this first one, A, if I plug in an x, I get out this y, right? If I plug in an x, I get out this y. If I plug in an x over here, I get out this y. So here's the point, right? So is this a function?
Yes.
A?
No.
Yes, it is, because every x has a y. Okay? How about in B? If I plug in an x, do I get out 2 y's or 1?
1.
I get out 1. So is B a function?
Yes.
Yes. So we say function. This is a function. But now C. If I plug in an x, do I get out just one y?
No.
So is that a function?
No.
Not. Okay. And in D, is that a function?
Yes.
Yes. Look at, when you plug in any one x, you get one y. Okay, the way that we can find this, an easy way, is to grab a vertical line. This is called a vertical line test. You can take this vertical line, and if I run it across the graph, if it only touches one point, it's a function. But if it touches 2 or more, it's not. You understand?
Yes.
Here you go. These were the functions, and there was one function that was not, or there was one graph that was not a function. We shouldn't call it a function at all. Okay, here's your assignment. Have fun.